Welcome back to my today's sessions of electromagnetic field, and this is the application of Gauss law and Maxwell's first law. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department, IARE, Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss one important thing of electrostatics, and that is nothing but the Gauss law. So from this topic, the students will be able to make use of Gauss law for obtaining electrical field intensity, density of uniform and non-uniform regions. So before starting, we will start some revision. What is electric flux density? Electrical flux density, or sometimes it is called the displacement density, is defined as the electric flux per unit area. So if we are keeping one charge here and there are electrical lines of force, electrical lines of force is known as the electrical flux. From the positive charge, it is always diverging in nature, and if the charge is negative, it is always converging in nature. So if the flux is phi, then flux density or displacement density d, that's why it is written as d. D is equal to phi by s, where s is the surface area. As the general tendency of the electrical charge is to lie on the outside surface, that's why we are writing it as the surface area. So, if we are taking the surface area as a sphere, we can write A is equal to 4 pi r square. So, D, what is D? D is nothing but the Q by 4 pi r square. Again, we know from the equation of the Coulomb's law, E is equal to Q by 4 pi epsilon 0 r square, and we get this important relation D is equal to epsilon 0 into E. It is for the free space. If it is in another medium, we can write D is equal to epsilon into E. So, this is the very important topic, D equals to epsilon into E. Now, what is Gauss law? The electric flux passing through any closed surface is equal to the total charge enclosed by the surface. So, already we have discussed in the previous slide, psi is equal to d psi by ds, we can write as the d. The displacement density or flux density is equal to d psi by ds. So what is psi? Psi is equal to d, it is a vector, dot ds. So if we integrate the both sides, we will get the total flux density, and number of flux is equal to the number of Q in a closed path. In a closed path is equal. So this is known as the Gauss law. So if this is a closed path, if number of charges are Q, we can see this is the ds and this is the delta s, and both are normal to each other. So we can discuss it in the vector form, that already we know D is equal to psi into ds. So if this is the electrical lines of flux and the surface is always, if this is the lines of flux and surface is always normal to it, surface is always normal to it. So we can write d psi is equal to total lines of flux casting to the or crossing to the normal to the surface ds. And what is ds? ds is nothing but the differential surface area. And we can write the unit vector by an. So this is the Gauss law in vector form, that d, we can write d is equal to d psi by ds in the direction is an. AN means normal to the surface. So now we will discuss about the applications of Gauss law. In my previous topic, or we can tell in my previous lecture on this topic, we have discussed many applications of Gauss law. Today we will discuss some more in this topic. So first we will discuss if we are taking a line charge and line charge is infinite in nature. Infinite line charge means we know the example of overhead lines. In the overhead lines, the point is from the current is flowing from one point to another point. If it is a long transmission line, we will think it is like an infinite line. So let's have, this is an infinite line and we will take it as a cylinder. So cylinder we are taking here because the line, overhead lines, or we think about underground cables, all nature is cylinder. So this is the length of this, and the length we are assuming as L. The length of this we are assuming of L, and consider the infinite charge density is rho L coulomb per meter square, and it is along the Z axis. If we keep the axis here, the length, if it is X, Y, Z, we can see this is along the Z axis, and the line charge density is rho L coulomb per meter. What is line charge density? Line charge density means charge per unit length. Next, consider the Gaussian surface, that the Gaussian surface as a right circular cylinder with Z axis and its radius is R. We are assuming the radius is R and the length is L. So the flux density on any point of the surface is always worked, as I discussed many times, that the flux density on any point on the surface always worked the radially. So direction of the flux will be in the radially, and we can write it as the AR direction. So this is the direction of the flux density. So again, now if we consider this diagram, we can draw it in a clear form. This is the same drawing, this is the cylinder, and this is the surface area, this is the Gaussian surface, and we are just assuming a small area ds here. We are assuming a small area ds here, and the distance of ds, is given as r. So this is, and the direction will be written as the AR. So the line charge is along the Z axis, and there cannot be any component of D in Z direction. Why? As we know that the general tendency of D is cut the 90 degree normal to the plane. As the direction of the flux is along the Z axis, so D, the flux density, cannot be stay at the D direction. So we can tell that D has only the radial component. So we already from the Gauss law we got Q is equal to surface integral of D dot ds. So this is our main circuit, and we can write that Q is equal to integration of D dot ds of top. Means when we are integrating the Q D dot ds, we will first integrate Q D dot ds of top, Q D dot ds of side, and Q D dot ds of bottom. Now, as we discussed earlier, that D don't have any component along Z axis. So we can write D dot ds equals to bottom and top equals to 0. That we can tell. as there is no component along the z axis. So only we have only this surface of the cylinder. Now, what is the surface of the cylinder? So we will take d dot ds, and the surface area of the cylinder is surface area of a cylinder can be written as the two pi r l. So here we in the state of 2 pi r l, as this is the circular in nature, we can write is at r into d phi. The small area of the circle can be written as we can write it as the r d phi. So we can also write it r d phi into l. So we are just putting the value of the side, and r d phi, and l is nothing but the dz. We are taking only the z. So we know r into d phi, already we have discussed, it is 2 pi r and length is l. So we can write that d dot ds is equal to 2 pi r dr into l. So r into phi d phi, and this is 2 pi dr into l. What is dr? dr is nothing but the q by 2 pi l, because what is dr? d is equal to psi by cross sectional area, and according to the Gauss law, q by s. So we can write q by 2 pi r into l. So d, again, what is dr? dr is nothing but the flux density along the line of radial, and we also can know that d is equal to epsilon into E. So what is E? If we just write from here, what is E? E is nothing but the, what is E? E is nothing but the q by 2 pi epsilon r l. Just we are putting the value, and this is the main equation. And what is q? As this is the line density, we know q is equal to, already discussed, q by l is equal to rho l. The line charge density is equal to charge per unit area. So we can write q is equal to rho l into l. And after just changing the value, dr is equal to rho l into l by 2 pi r l, we got d is equal to rho l by 2 pi r l, and direction is in the AR direction. As I told, that rho l is equal to q by l. So what is E? If we put the value in E, so it is rho l 2 pi epsilon r AR, and this is the Coulomb's law. We can prove it from the Coulomb's law also. For an infinitely long current carrying conductor, the intensity is equal to rho l 2 pi epsilon r, and direction is AR. Now we will think about the coaxial cable. What is the meaning of coaxial cable? Coaxial cable means this is also a cylinder, and there are two coaxial cylinders will form the one coaxial, like this. This is one cylinder, the yellow one is cylinder, and their axis is same. That's why they are known as the coaxial cable. Now we are thinking about the radius. It has two. What is the length of this cable? The length of this cable has been taken as L, and the radius of the inner conductor is taken as A, and the outer conductor has been taken as B. And we are taking as this is a cylindrical coaxial, so there is a mismatch of surface, that's why we are taking the flux density as the rho s, where rho s is nothing but the surface charge density. And what is the total outer surface? The outer surface, the total surface area of the outer surface is, if it is A, the outer surface of the inner conductor. The outer surface of the inner conductor will be 2 pi AL. And similarly, the surface, so if it is the A, the radius is A, we can write it as the 2 pi AL. If the radius is B, then what will be the value? It will be 2 pi BL. The total surface area of the outer conductor will be similarly 2 pi BL. So, hence rho S, the rho S, already we have discussed the rho S. Rho S is equal to the surface charge density, can be expressed in the terms of rho L. So, how to we can write that the rho S? How we can write this? We know that the rho S is equal to, what is rho S? Rho S means total charge by the total surface area. And here the surface area is nothing but the 2 pi r into L. For the inner surface, for the inner cylinder, if the radius is A, we can write Q by 2 pi A into L. Now, if we are concentrating only in the inner one, if we are concentrating only in the inner cylinder, what will happen in that case? In the case of the inner if the charge density, line charge density is rho L, we can write rho L into L by 2 pi AL. L cancel out, so we can write rho L is equal to rho S into 2 pi A. So similarly, we can also write the right circular triangle of L. We are also just imagining that this is a right circular cylinder of length L, and the Gaussian and due to the symmetry, the D has only the radial component. There is no component along the Z axis. So already I have discussed this one, the relation between rho L. Rho L is equal to rho S into surface area by length. Surface area is 2 pi AL. So from here we got the rho L is equal to rho S into 2 pi A. So this is, so similarly we can write also the, for the outer surface, what is rho L? Rho L is equal to rho S 2 pi into B. This is for the outer one. So this is the coaxial cable. We have got A and B. Now what is D? From the previous one, for a single circuit, we wrote that D is equal to rho L 2 pi R AR. Now we just, in the previous slide, we have changed the rho L by rho S 2 pi A by 2 pi R. So what is D? If we change it, it will come rho S A by R. 2 pi cancel out, and it will come rho S A by R. So this is the value we got for the inner one. So every flux starting from the positive charge, if we give the positive charge on the inner cylinder, there must be the negative charge will be induced on the outer cylinder. If we connect the cylinder with any external source and we are giving positive charge on here, the negative charge will come on the outer surface of the outer cylinder. So, the total charge of the inner surface of the outer cylinder is in the negative, and if Q inner will be minus rho S 2 pi AL, if where rho S is the charge density, 2 pi AL is the total surface density, and Q outer is equal to rho S outer 2 pi BL. Why 2 pi BL? B is the radius of the outer one. So what is rho S outer? If we divide this equation by this equation, we can get rho S outer is equal to minus of A by B rho S inner. So this is the relation between the flux density of a cylinder of a coaxial cable. Now we will discuss about the infinite sheet of charge. What does it mean? Again, it will think about the infinite sheet of charge means this is the sheet of the charge, and the infinite sheet means this is a surface, and the x and y axis is infinite. So we are again considering the infinite sheet of charge of rho S coulomb per meter square. So what is the charge density? The charge density is rho S coulomb per meter square, and it lies in the xy plane. As this is a surface, so we can think that it is always in the xy plane. So consider a rectangular box as a Gaussian surface which is cut by the sheet of charge that ds is equal to dx dy. What does it mean? Previously we are thinking about the cylinder, but in this case we will take the example of a box, and if we cut the box, if this is the box, and if we cut the box like in the middle, like the cross sectionally, we will get the surface. And what is the surface area? The surface area is ds is equal to dx into dy. So just check this diagram. So this is the surface, and we are just, this is a box, and we are cutting a surface. We are cutting this surface here. You can see we are cutting this surface here. So it has only z is constant for this surface, and we are getting only x and y. This is the z plane, and this is the d, and like similarly d is now in the z direction. Previously d has no z direction, but in this case d has the, and for this sheet the surface charge density we are taking as the rho s. This is a x, y, z axis. So again similarly we can think, when we are thinking about this box, so how many surfaces we have? We have total 6 surfaces. Top, bottom, one pair of side, another pair of side. So while we are thinking about this surface, top surface, bottom surface, one side, one pair of side, one pair of side. So according to the Gauss law, Q is equal to closed loop surface integral of d dot ds. So now we will get it, one for the top, one for the bottom, one for the one pair of side. This is for the another pair of side. Now what is the d dot ds? Now as I told that the d, always the general tendency of the flux density is normal. So if this is the xy plane, normal means it has only z direction. Z direction means it has the direction on the top and it has the direction in the bottom. There is no side component. So in the side, d dot ds for the both side is 0, as we don't have any side component. So now our equation has been minimized, and q is equal to d dot ds top plus q d dot ds bottom. So what is ds? As it is an xy plane, we can tell that the ds is nothing but the dx into dy. What is this? Dx is equal to d dot dx into dy. Similarly, for the bottom also, d is equal to dx dy. So, as this is the same thing, so we can write q integration of d into dx by dy. So, this is known as the q. So, if we calculate the equation, what is the integration? The integration will be q is equal to d. And what is the meaning of dx dy? Dx dy integration of dx dy. And what is the integration of dx dy? D into, we can write this is the A, where A is the surface area. We got A is the surface area. And there is a term 2 because this is for the top and bottom. So what is D? D is nothing but the Q by 2. What is D from this equation? Q by 2A. This is D. Now what is Q by A? Rho S. According to the definition, the surface charge density rho S equals to Q by A. So if we compare this equation with this equation, we will get D is equal to rho S by 2. So this is the equation we got. D is equal to rho S by 2. So we can see that the Q is equal to integration of top surface, bottom surface and two pairs of side. As there is only the Z component, there is no XY component. So we can just remove the side component. So Q is equal to integration of d dot dx dy plus top of and q d dot dx dy of the bottom surface. So for integration, as both are same, we can write q is equal to 2 that closed loop integration of d dot dx dy, and dx dy is nothing but the cross sectional area. And what is d? D is basically, here we are taking only the z component. Now we are coming to the last portion of this talk, and that is the Maxwell's first equation in the point form. And the Maxwell's first equation is very, very important, and we can write this. So from the Gauss law, we already got Q is equal to D dot ds. We got already the equation D dot ds. What is this? This is the Gauss law. Q is equal to D dot ds. And this is the surface integral. Now surface integral means number of time integration is how many times? This is the 2-time integration. D dot dx into dy, or we can write Q is equal to D dot dx dy, as we discussed in the previous one. Now, according to the divergence theorem, if we want to change the label, what does it mean? If we want to change from the surface integration to the volume integration, we will take the grad of this equation. We will take the grad of the equation. So we can write we are doing the volume integration. So integration of grad dot d is equal to dv. This is the volume integration of the line. We can write Q is equal to grad dot d. What is the grad? Grad is a component, and grad is equal to del by del x plus del by del y plus del by del z. So we have the grad operator has 3 parts, and grad dot d, we will get the total charge Q into dv. Again, according to the definition, what is the definition of the charge? That we can write from the if rho v is the volume charge density. Already we have discussed these things, just one repetition. Volume charge density. So what is rho v? Rho v can be written as the total charge by total volume dq by dv. So what is the value of q? Q is equal to the volume integration of rho v dv. So q is equal to the volume integration of rho v dv. And we got this here, that the q is equal to rho v into dv. So if we compare the equation 1 with equation 2, what we will get? We will get the grad dot d is equal to rho v. And this is the Maxwell's first equation in the point form. This is the Maxwell's first equation in point form. So today's topic we have discussed about the Gauss law, the application of Gauss law. Third one is the Gauss law for a cylinder. Fourth one, we discussed about the Gauss law for an coaxial cylinder. Coaxial cylinder means it has the same axis. Then we have discussed about the Gauss law about the Gauss law of the infinite sheet. And then we have discussed about the Maxwell's first equation in the point form. This is the one of the important topic, Maxwell's first equation in point form. So this is the today's topic of this chapter, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.